Next we have value function. Whereas the reward signal indicates what is good in an immediate sense, a value function specifies what is good in the long run. In reinforcement learning, RL, the value function is a function that estimates the expected cumulative reward that an agent can obtain by following a specific policy from a given state. The value function is an essential component of many RL algorithms since it provides a way to evaluate the quality of different policies. The value function can be defined in two ways. State value function. The state value function is a function that estimates the expected cumulative reward that an agent can obtain from a given state following a particular policy. Action value function. The action value function is a function that estimates the expected cumulative reward that an agent can obtain from a given state and taking a particular action following a particular policy. The value function is a crucial component of many RL algorithms since it provides a way to compare different policies and select the optimal one. The value function can be learned through various techniques such as Monte Carlo methods, temporal difference learning, and Q-learning. The value function is used to guide the agent's behavior towards achieving the desired outcome. The agent learns to estimate the value function and adjusts its policy accordingly to maximize the expected cumulative reward. The ultimate goal of the agent is to learn the optimal value function, which corresponds to the optimal policy that maximizes the expected cumulative reward over time. We can say rewards are in a sense primary, whereas values, as predictions of rewards, are secondary. Without rewards there could be no values, and the only purpose of estimating values is to achieve more reward. Nevertheless, it is values with which we are most concerned when making and evaluating decisions. Action choices are made based on value judgments. But it is much harder to determine values than it is to determine rewards. Rewards are basically given directly by the environment, but values must be estimated and re-estimated from the sequences of observations an agent makes over its entire lifetime. The fourth and final element of some reinforcement learning systems is a model of the environment. Model of the environment is something that mimics the behavior of the environment, or more generally, that allows inferences to be made about how the environment will behave. The model can be used for planning and decision-making, allowing the agent to simulate possible future trajectories and select the optimal action. The model of the environment can be represented in different ways, depending on the nature of the problem and the available information about the environment. In some cases, the model may be explicit, meaning that the agent has full knowledge of the environment's dynamics, including the transition probabilities and the rewards associated with each state action pair. In other cases, the model may be implicit, meaning that the agent has limited or incomplete knowledge of the environment's dynamics, and it needs to learn the model from experience. Methods for solving reinforcement learning problems that use models and planning are called model-based methods, as opposed to simpler model-free methods that are explicitly trial-and-error learners, viewed as almost the opposite of planning. The model of the environment is not always necessary in RL, and many RL algorithms can learn directly from experience without an explicit model. However, having a model can be useful in some scenarios, such as when the environment is complex and exploration is expensive or time-consuming.